Now we study the last application of sine rule and cosine rule, which is called as Napiers analogies. Now here the result states that in any triangle ABC, tan of b minus c upon 2 is equal to b minus c upon b plus c into cot of a by 2. Now to prove this result, we start off with right hand side. Alright, so let us substitute for b and c on the right hand side. So as we know, b can be written as k sin b and c can be written as k sin c whole upon k sin b plus k sin c into cot of a by 2 as it is. Now cancelling k from numerator and denominator of the bracket, we have sin b minus sin c upon sin b plus sin c into cot of a by 2. If you look at left side, we have the half angle form, that is b minus c by 2. So that means it gives us a hint that the expressions that we have got inside the bracket must be factorized so that we will get the half angle terms. So sin b minus sin c is nothing but 2 cos b plus c by 2 into sin b minus c by 2 upon sin b plus sin c is 2 sin b plus c by 2 into cos b minus c by 2. So here we see that everything has been converted into half angle. But on the remaining term, that is cot a by 2, we can write cos of a by 2 upon sin of a by 2, because the reason is that the moment we see the term cos of b plus c by 2, it's clear that that is already equal to sin of a by 2 because of the properties of angles of a triangle. So that can be cancelled with sin a by 2. Similarly, sin of b plus c by 2 is same as cos of a by 2 in a triangle, so therefore that is cancelled. 2 also gets cancelled. So therefore what remains is sin of b minus c by 2 upon cos of b minus c by 2, which is nothing but tan of b minus c upon 2, and that is the left hand side. Right. So in this way we prove the Napiers analogies. Similarly, the other two statements can also be written, that is here it was b minus c upon 2. In the other two we will have a minus b upon 2 and c minus a upon 2. Yeah. Let's go ahead and see how we can use Napiers analogies to solve the problem. Here in triangle ABC, a is root 3 plus 1, b is root 3 minus 1 and angle C is 60 degrees. Then we have to find angles A and B. So here if we look at what is given to us and what is that we have to find, we see A, which is nothing but side BC, is given to us. B is nothing but side AC, that is also given to us, and we are given angle C to be equal to 60 degrees. So if we see, we are given two sides and an included angle, right? So in this case, Napiers analogies are very convenient. Alright, so let us write the statement for Napiers analogies. If we see that A and B are given to us, so therefore we will use the statement tan of A minus B upon 2 is equal to small a minus b upon a plus b into cot of the third vertex, that is the third letter, which is c by 2. Right. So therefore we get a is root 3 plus 1 minus b is root 3 minus 1 upon root 3 plus 1 plus root 3 minus 1 into cot of, now c is 60 degrees, so therefore c by 2 is 30 degrees. Now in the numerator, root 3 gets cancelled and we have 1 minus minus 1, that is equal to 2, and in the denominator 1 gets cancelled, so we have root 3 plus root 3, which is 2 root 3, and cot of 30 degrees is nothing but root 3, so therefore all terms get cancelled and we are left with 1. So that means tan of a minus b upon 2 is equal to 1. That means the angle a minus b upon 2 must be 45 degrees, and hence we get a minus b must be 90 degrees. So that means we have got the difference of two angles a and b to be equal to 90 degrees. Now if we look back at the data, we are given the value of angle c, right? So that means a plus b plus c, which is 60 degrees, has to be equal to 180 degrees, right? So therefore we basically have a plus b equal to 120 degrees. So therefore we have two equations in a and b which we solve simultaneously and easily get the value of a as 105 degrees and value of b as 15 degrees. So that is the answer, and we have found the values of angles a and b using Napier's analogies.